This composite illustrates the central tension of the coffee trade. On the left, we have raw agricultural output, millions of individual seeds subject to unpredictable weather, pests, and soil conditions. On the right, the strict mathematical parameters used to classify them. Global commodity markets rely on certainty. Buyers executing million-dollar purchase contracts require absolute objective standards to guarantee they are getting exactly what they pay for. But the final arbiter of coffee quality is inherently biological. The value of the product is ultimately decided by subjective human taste and smell, variables that differ wildly from person to person. To solve this paradox, the Specialty Coffee Association and the Coffee Quality Institute developed a standardized global grading system. The protocol functions as a strict multi-stage algorithm designed to calibrate the human sensor and eliminate personal bias. The algorithm dictates 3 distinct phases of evaluation: physical evaluation of the raw seeds, strict environmental preparation tolerances, and finally, a 16-point sensory matrix. By forcing subjective human experiences through these rigid constraints, the industry converts biological perception into universally recognized objective data points. The evaluation begins with physical metrology. To ensure mathematical consistency, the entire physical grading process is strictly bounded by an exact 350-gram sample of green coffee. This is the Arabica Green Grading Test Sheet, logging flaws in the 350-gram sample. The matrix splits flaws into severity tiers. Category 1 primary defects have severe cup impact. Category 2 secondary defects cause minor degradation. Graders calculate penalties using the full defect equivalent formula. The algorithmic rule states that a full defect cannot be a fraction. Single defects are grouped together and rounded down to the nearest integer to generate the true penalty score. Take this Category 1 primary defect, fungus damage. Fungal growth introduces moldy, phenolic compounds into the seed structure, destroying the cup profile. Because the damage is so severe, it carries a 1-to-1 penalty. A single fungus-damaged bean equals 1 full defect. Another high-impact Category 1 flaw is the dried cherry pod, where the seed remains trapped in its fruit casing, inviting heavy fermentation and contamination during shipping. The protocol also requires precise visual thresholds for identification. To classify a bean as a full sour primary defect, an orange or red color must fully penetrate the physical body of the bean. Superficial staining on the outer silver skin does not count. To pass this initial physical stage, the sample must meet an exact threshold, 0 Category 1 defects and no more than 5 Category 2 defects. If the sample fails this metric, the evaluation stops. This sorting phase acts as a strict gatekeeper, filtering out structurally compromised material before heat or water are ever introduced. Once the physical structure is verified, the algorithm moves to the preparation phase. Even flawless green coffee will yield skewed data if the roasting or brewing environments fluctuate. Roasting is tightly controlled. The sample must finish roasting between exactly 8 and 12 minutes, followed by immediate air cooling. Water quenching is strictly prohibited. This gauge shows the mandatory colorimetric standard for the roasted sample. To ensure uniform caramelization and solubility worldwide, the coffee must hit an Agtron Gourmet score of 63.0, with a microscopic tolerance of plus or minus 1.0 unit. Time is also constrained. The roasted coffee must rest for at least 8 hours, but the sensory evaluation must occur within 24 hours of roasting. Once ground, the clock accelerates. Water must hit the grounds within 15 minutes. The brewing ratio locks into the midpoint of the Golden Cup standard, exactly 55 grams of coffee per liter of water, scaling precisely to the volume of the cupping bowls. The solvent itself is regulated. Cupping water must contain between 125 and 175 parts per million of total dissolved solids, poured directly over the grounds at roughly 200 degrees Fahrenheit. These severe constraints serve a specific mechanical purpose. By locking the extraction variables into place, the protocol isolates the human sensor, forcing the grader to measure only the inherent chemical qualities of the seed. This diagram illustrates the sensory evaluation sequence. Cupping relies on a timed thermal decay process, where shifting temperatures reveal volatile compounds. At 200 degrees Fahrenheit, the grader executes the first measurements, scoring dry fragrance, then wet aroma as extraction initiates. 3 to 5 minutes after the pour, the grader physically breaks the crust of floating grounds. This action releases a concentrated burst of trapped gases, allowing for a precise evaluation of the wet aroma. 8 to 10 minutes later, the sample cools into the 160 to 140 degree window. Here, the grater slurps the liquid to score flavor and aftertaste. This temperature node is specifically chosen because retronasal vapors, the aromatic compounds traveling from the mouth up into the nasal cavity, reach their absolute maximum intensity at this heat level. While in this cooling window, the grater also logs scores for acidity, body, and the overall balance of those components. Finally, as the temperature drops below 100 degrees, the protocol dictates the scoring of sweetness, uniformity across multiple cups, and clean cup transparency. At this cooler stage, the heavy aromatic volatiles have dissipated, allowing brew colloids and long-chain sucrose carbohydrates to dominate the palate. Throughout this timeline, graters also scan for sensory defects. A noticeable off-aroma is a taint, carrying a -2-point penalty. An overwhelming taste is a fault, penalized by -4 points. The Q grater acts as a biological instrument, utilizing temperature decay to sequentially isolate, measure, and log specific chemical attributes into a data matrix. Looking at the bottom right corner of the grading sheet, we can see how this sensory data translates into a definitive mathematical output. First, the individual scores from the 16-point scale, covering aroma, flavor, body, and acidity, are summed to generate the total score. Added are Cupper's points, the only space for holistic human appraisal of expected origin characteristics. From that combined number, the grater subtracts the intensity scores of any recorded taints or faults. The remaining number is the final score. The global threshold is absolute. A final score landing between 80.0 and 100 earns the legal classification of specialty grade. A final score of 79.99 or below designates the coffee as below specialty quality. That fraction of a point drops the coffee into commodity status, drastically reducing its value on the global market. The specialty classification represents a hard, verifiable data point generated through rigorous physical metrology and calibrated human sensory evaluation.